So going back to our initial question, how are these different? And the follow-up, do they behave differently? And then beyond that, how do they behave differently? And if we can get beyond that, why are they behaving differently? I've heard people talking about all of these things, but I've heard different ideas. So any thoughts on how are these different? What have you noticed? What have you found out?
We noticed you labeled them differently.
Labeled what differently?
Their murky water is B, and our murky water is A.
Oh, so you notice, so one variable is, actually I'm going to kind of keep track of variables a little bit as we're talking. So there's this variable of murkiness. And you found that which one of theirs is, B is more murky, but yours, A, is more murky. Okay. What else did people discover? Smells different? Which, you mean A and B, or the balloons? Or? Okay, so B has an, so smell is something that might be a variable. Or what? B was sticky, so stickiness. Okay, what else was found out?
So the color is the same as murkiness, right? This one, A is a clear color, down, cloudy.
Okay. But it sounds like one group had a different, do you think your A is more cloudy? B is more cloudy? Is that true for everyone? Or no, yours? A looked cloudier than B. Okay.
I saw like white sediments on our bottom for A.
Ah, so you saw some sediments, white sediments, huh? So we're getting at lots of observations. What about how they behave differently? Because maybe we can connect some of these observations to the behavior that you observed. Okay. So rising, could I say floating?
Yeah.
So floating is a variable. And I noticed a few groups found that there were differences in floating. And sort of a subpoint of that you mentioned was sort of speed. Like if it floated, some floated quickly and others, did other groups find that as well, that there were differences in speed of floating? Okay. Okay, so a variable which is color of the balloon, you found the two balloons that were the same color behave differently. Yeah. Did any other groups find that?
Yes.
So can we say that color of balloon is not related to its behavior? Right? Can we look at a pink balloon and know how it's going to behave based on the fact that it's pink? Okay. So you're saying maybe what the liquid inside the balloon is key. Okay? So I'm going to just tentatively, that wasn't very tentative to knock all those push pins on the floor. That was a very bold maneuver. But tentatively, I'm going to cross out color because it seems like color might be a variable that does not have bearing on the behavior. And it seems like multiple groups found that to be true.
We had red as the only one that sank.
Okay, so in your group, red was the only, and what did it sink in?
Solution A, which was our murkier, cloudier, whiter.
Okay, so red balloons sank in A. Did anyone else have a red balloon that sank in A?
Yes, we did.
You did. Did anyone have a red balloon that floated in A?
Yes.
Okay. So in your example, sometimes, right, depending on how big our sample size is, it's hard to tell if a variable is meaningful or not. So in this case, we're kind of drawing on the larger sampling of balloons. And while if we were to just go with your group, we might say color is an issue because red was the only one. But sometimes if we get a larger sample, that causes us to question that, right? And with science, it's always, does it support that hypothesis or does it not support it? So your experience supported the idea that red might be key, that the color might be key, but other groups' experiences supported the fact that maybe color is not an issue. Okay? Other comments on behavior of the balloons?
The position that it floated in.
Okay, so there were differences not only in floating speed, but sort of how much it floated or position. Can you describe what you mean by position? Differences in position.
Some wanted the tie at the top, and some of them had the tie at the side.
Okay. So there were sort of two positions. One was, this is one option, and the other one, it sounds like it's sort of floating horizontally or vertically. Okay? Did other groups find that as well? That there were differences in how they floated? And it's good to talk with a lot of scientists because, right, that may raise a question that's worth following up and investigating. Your group found that. I'm not seeing other groups nodding, yes, they found it. It doesn't mean you didn't find something that's valid, right? It could mean that other groups need to follow up and see if they also find that. Now that we have this observation, we can follow up and see if that's consistent with other people's experiences. Yeah? If I were to do this, sorry, this is like the saddest little marker that ever there was. Maybe this one's better. Much better. All right. So, are there generalizations that we can make about these two liquids? Other than, for the most part, well, one group said that there were differences in terms of cloudiness. But that wasn't true for all groups necessarily. Were there differences in how things behaved in the two?
In B, we had the majority of floating. And in A, we had the majority of sinking.
Majority or 100%?
Majority.
So some did sink and beat?
We had one sink in B.
Oh.
Is that unusual? Did other groups find?
No, we didn't have any sinkers in beat.
And you said majority floated. Is that true for other groups that the majority floated in? Oh, wait, sorry, the majority sank in A? Or would you?
No, equal parts.
We had some that sank in A though.
Yeah.
So can I say some sank and some floated? So this one was a little bit unusual, yeah? Because it sounds like only one group had one that sank. Anyone want to put forward an explanation of, we've talked a little bit about how, any ideas on why, based on your experiments or other? Okay, so salt water versus regular. Did other people have that hypothesis, or does someone have a different hypothesis? I heard one yes. And do you mean saltwater versus regular in these containers? Or are we talking about in the balloons? Are we talking in the containers or the balloons?
Container.
In the containers. If we were to say one of these is saltwater, anyone have a hypothesis about which one would be the saltwater? B. Whoa, lots of people thought B. Why? Saltwater, so you have some background knowledge about saltwater. You said saltwater is more dense? More dense than what? More dense than regular water. So things that are less dense float and things that are more dense. Okay?
Smell factor.
Okay, so you're using also, this proved to be a variable that might be significant. Yeah? Or at least it seems to coordinate with this idea, well, salt water is more dense, and also you said that B had a smell that seemed ocean-like. Okay. All right. So we could keep going with this, but I'm going to do the big reveal at this point. And I will tell you this, that cloudiness was a little bit, or murkiness was a little bit of a red herring. When we prepared the solutions, we did use salt for one of them, and we found that even if we stirred it a lot, it still was a little cloudy. So we had to add just a little bit of Elmer's glue to the other solution to create a cloudiness. Now, we may have added unequal amounts of Elmer's glue to the other one, which could represent, or could explain why some group found that one to be more cloudy. And in fact, B was the saltwater one, whereas A was freshwater with a little bit of Elmer's glue. However, some of the balloons also have salt water, and some had fresh water in them. So this idea that it has to do with the liquid inside, that's accurate. There's probably some variables here, though, because we couldn't tightly control how much liquid we are putting in. We tried to put a similar amount of salt in each of the saltwater balloons, but that concentration probably varied. If we could have created one solution that was all consistently the same and then used a pump to fill up the balloons, that would have been a more consistent way. But I thought it was kind of fun to have some variability with that aspect as well, right? Because the world is messy and not neat and tidy as we go to investigate it. So I think that added a certain level of challenge to this little task, that there were some differences probably in floating. Thinking about sort of larger context of this, I wanted to go with this because it has particular significance for Hawaii, because all of the fresh water that we depend on for drinking floats, right, forms a lens on top of the salt water that permeates underneath the island. And so if fresh water did not behave as it does on top of salt water, we wouldn't have a viable source of fresh water here. And so you can take an investigation like this and you can tie it into a larger topic, right? Thinking about water use on Oahu or in the Hawaiian Islands, or looking at something like changes in salinity in tide pools and how that affects the things living there. Or there's all sorts of different directions. You could go sort of the molecular route. Why is salt water more dense than fresh water? Why do denser things sink in the presence of less dense things? Nikki, did you have it?
Like the background knowledge, like kids go swimming, so they know you're more floating in saltwater ocean rather than in the pool.
Yeah, they might have a very personal experience of that, right? Where they have actually physically felt that difference in salinity. You could show them pictures of the Dead Sea and people just floating like corks in there. Yeah. So it's a topic that has a lot of depth to it and different angles you can go. I like approaching it from an inquiry standpoint, though, because it really lets you kind of grapple with it. And there's even things I don't know about this, even though I set up the experiment with Emily. Like, what about the balloon latex? Like, is that a factor? Like, how come the fresh floated in the fresh? Is that because of like the balloon, or was there a little bit of air in there? There's still things that I have kind of questions about, like how much difference does it make? We could really get particular about this. Like, if I double the amount of salt, does that double the speed at which double the speed at which that saltwater balloon sinks in fresh water? Or is there a linear relation, right? There's all sorts of ways you could go. I really appreciated sort of the use of artwork, though, also in documenting, because I think what I noticed is it gave people a way to visually keep track of what was happening. And I think going that route with students gives them a way into science, whereas if you're just giving them a chart to keep track of results and it's all writing, they're not forming this image. So anyways, that's our science investigation for the day.